Hello everyone, my name is Brahmjot Singh. In this video, I am going to walk through my assignment 2 for COMP 3122 Applied Data Science. I'll explain both parts, part A, the decision tree, and part B, the pandas data analysis. I'll also connect my code back to what we learned in the course, such as Python, NumPy, pandas, machine learning with scikit-learn, etc. So coming to the part A, the decision tree model. The goal is to use a decision tree model from scikit-learn to predict if a person has COVID-19 or not. I've used a CSV file here. Let me show you. So this is the CSV file I used. You can see the columns and all the data here. Coming back to the code, first of all, at the top of notebook, you can see there are some features such as age, gender, fever, cough city with a targeted column called has COVID, which has values such as yes or no. So here I imported some libraries such as pandas for working with tabular form, train test split and decision tree classifier from scikit-learn, and accuracy score to measure the how the model performs. So this directly uses our course outcomes where we apply Python libraries like pandas, scikit-learn to transform, visualize, and model data. And we also explain and test machine learning models. So this is what we used here. Here I read CSV using pd.read CSV URL to show the first few rows with head and info, as you can see here. So this lets me check that file loaded correctly and see the data types. You can see the data types here. So here, um, next, I separate features and labels. I create X by dropping the has COVID column. I create Y by mapping has COVID to 0. Um, like no becomes 0 here and yes becomes 1. So this is needed because scikit-learn models work with numbers, not strings. A lot of columns in X are categorical like gender, rough, city, as you can see. So to handle that, I use pd.getDummies for to create one hot encoded dummy variables. So we also practiced encoding categorical dates and dummy variables near the end of course. So this step links back to those lectures. Train test split and model training. If we come down, you can see that I use 30% of data as test data. So I set test size to 0.30, as you can see. I also set random state equals 42. So the split is reproducible and I use 25 equals y to keep the same proportion of positive and negative cases in both um, data we trained on. So that connects to again those course outcomes where we train and test models and choose evaluation metrics. Splitting the data stops us from accidentally testing on data we trained on. So then I create decision tree classifier with a fixed random state and call.fit. You can see xtrain, ytrain. We study decision trees in the classification section, especially like this assignment is like repeating that idea on COVID dataset. Evaluation, if you will come here, you can see that to evaluate and model, I run predict on X test, y pred. So accuracy is one of the main metrics we used in the class for also for classification problems. So it fits the course learning outcome of selecting appropriate metrics. So this also um, helps here a lot. So in my notebook, I print the training and test sizes, then accuracy as a decimal rounded to 3 places, as you can see here. So part A summary would be like loading the data, encoding categories, splitting into train and test, training the decision tree, and then evaluating it. So this is all we did in part A. You can see that like I also wrote some of the points and as a short reflection for the part A. Coming to the part B, I'll do a question by question walkthrough here. First, I import pandas and matplotlib.pyplot, turn on this %matplotlib inline and read the CSV using pd.read CSV. I display head of the data frame and use df.info, as you can see here. This is here, df.info, to understand the columns and data types before starting the questions. So first question is this one. Here, I deleted the model column. So it asked me to permanently delete the model one column. So I just use drop columns equals model in place equals true. So so that the change is permanent. So to confirm it's deleted, print df dot columns, and you can see the output here, which proves that the particular columns has been deleted. Coming to the question two, it asks to clean the cost column and check type. So I do this using a string replaced with a regular expression. You can see that I use this code here, replace method, and again this uses string methods on a pandas series, which was also one of the topic from the course. Then I print a few rows of cost and also print df cost dot d type to show the type after cheating. You can see here. Oh, okay. Oh, not cheating. Actually, it's cleaning. Sorry. So convert cost to integer. Here, question 3 wants us to cost column converted to integer. After cleaning, cost is still text, so I convert it with df cost equals df cost dot s type int. I print the d type again to confirm it's now int. This is important because later questions need numerical operations like mean, histograms, etc. So you can see the output here. And coming to the question fourth, average cost and average by continent. And here, part A, you can see that I compute overall average of cost column using df cost dot mean, and then I compute average cost per continent using df dot group by dot means method. You can see here. As a result, this uses group by, which is a powerful tool we learned for aggregations, and it connects directly to the course outcome of using pandas to transform and summarize data. You will see the output here. Question fifth asks for a bar chart of mean cost grouped by continent. So I reuse the grouped mean from question 4, and I call average cost by continent dot plot kind equals bar. So then I set the title and access labels and call plot dot show. This uses matplotlib visualization through pandas, which matches the course topic on histograms, column charts, and other plots. As a result, I got this histogram here. So coming to the next question, here it's asking for counting how many times each continent appears in the continent column. I just simply use df continent.value counts, and as a result, value counts is a quick way to see frequency distribution, and I got this. Next question asks to display unique values in the continent column and count them. So for this question, I display the unique continent values and total number of unique continents, and I use df continent.unique. You can see, and I used len unique continents for displaying total number of um, the unique continents. So this is basically the exploration that helps understand categories in the data. Coming to the next question. So this question asks me to use value counts on the cost column and describe the output in a comment. So I store it as cost counts and print it. In a comment, I explain that each line shows a cost value and how many rows that have that exact cost, and that values at the top are most common ones. So I'm not just reading the function, I also explain what numbers actually mean. You can see. So this is the histogram. So I simply, this question asks for a histogram of cost column with the bonus of using 50 bins. So I use this here. You can see and histograms. Then I label the axis and title. Like this histogram are exactly that what we used in the class to visualize one distribution. So this again connects to the visualization part of the course. Coming to the next question, missing values in zip code, type, and full data frame. So this question focuses on missing data. First, I count missing values in zip code and date and type with this code here, and then I print df dot isna dot sum to summarize how many null values each column has. So this matches the handle missing values part in the advanced panda sections, which we learned. So statistics for type including NA and then fill with XX X. So Here it asks me to show the statistics for type including any and values, then replace those missing values with this. So I used this method here, you can see, and so that any and values are included. Then I fill the missing values with this one. So after that, I show number of missing values is now 0 in type. So this is another example of data cleaning, which is crucial before any machine learning. Coming to the next question, it asks to drop all rows with missing values. How many rows remain? So I use simply this and this to um, show that how much data is lost when we require full complete rows, which is something we think about when preparing data for models. In question 13, I use cleaned df no missing data frame. I call this here, which gives summary statistics like count, mean, standard deviation, min, and for all the numeric values like the columns. Then I access the first row and third column using this here. Question 14. So this asks us to sort value counts of continent by frequency, then alphabetically. So I use simply this to then I convert to data frame, so I can sort on two columns. So you can show see the code. This gives me a table where continents are ordered from most frequent to least frequent, and ties are broken alphabetically. So summarize part B, clean string data and convert it to integers, and then I computed average and group data by continent, created bar charts and histograms, detect and fix missing values, and generate descriptive statistics. So all of this directly matches our course outcomes, like using Python libraries, um, like NumPy, Pandas, and Matplotlib to transform and visualize data, and using machine learning algorithms from scikit-learn to build and evaluate models. So that's the end of my explanation for assignment 2. Thank you so much for watching.